In this module, I'll go over some basic arithmetic circuits and show you how to write basic test benches in Verilog. Specifically, my ultimate goal in this project is to show you how to build simple circuit elements that can perform arithmetic operations. I'll go over the process of addition or the operation of addition, and I'll show you how to build simple adders in Verilog. And then I will go over some techniques that make your code scalable, general. Sometimes it's called generic, and I'll refer to it as parameterized, or the process of parameterization of your code. And that will allow you to take any code you write and use it across not only modules within the same project, but you can actually reuse your code in several projects over and over again. So your code will be very general and you can use it all over the place. And then I'll move on to covering a little bit about subtractors, and subtraction is just another arithmetic operation, so I just want to show you another arithmetic circuit. And frankly speaking, I'll be taking the adder that we'll be developing at the very first step here, and we'll just modify it a little bit and we'll make it a subtractor. And then I want to cover a little bit about signed numbers and how do we deal with signed numbers and the type of errors that occur when signed numbers or when we do basic arithmetic like addition and subtraction with signed number. And specifically, I'll talk a little bit about what overflow is in terms of signed numbers. And then I'm going to go and cover some Verilog operators, specifically the arithmetic operators, and we'll see how we can actually utilize them to do basic arithmetic as well. And then, since we're covering arithmetic operations, you will be faced with cases where you need to write number literals. For example, you might want to say, well, I want the number 15, or maybe the number AF in hex, or maybe the number 1010, or even in oct, for example, maybe we can do an oct that doesn't have 8, but has like 7, 1, for example, and that's an oct if you want to. So I'll go over how you can enter these numbers or represent them in Verilog and embed them in your code. And finally, I'll go over some basics of behavioral testing in Verilog and how to write simple test benches. So let's get started.